All right, so we are going to start something totally new today. This is section 9.1. It's called sequences. And what a sequence is it's an ordered list of numbers. And actually, the last thing I'm going to teach you today is something that's going to make me a little bit uncomfortable. So stay tuned for the ending. I hope you enjoy it as much as it made me very uncomfortable. So when we have a sequence, generally we use the notation A sub n, where this pretty much means the nth number in a sequence. So for example, we could have the notation. First number would be a sub 1, then a sub 2, a sub 3, and a sub 4. The number term in the sequence would be the first, second, third, and fourth. And then the actual term itself, like the first term might be 2, the second term might be 4, then we have 6, and then we have 8, and that pattern just keeps going on for forever. Now if you take a look, it looks like to get the actual term, you do 2 times the number term. So like 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and that just goes on for forever. So the notation for this sequence, the notation would be the nth term in the sequence would equal 2 times whatever number term that term is. So like the 8th term would be 2 times 8, which is 16. That's how we could do this. Now just some definitions. A finite sequence ends. Finite as opposed to an infinite sequence is a list that goes on forever. We have what's called a geometric sequence. And what geometric means is that to get the next term in the sequence, you multiply the previous one by a constant. Or we could just say terms that are reached by multiplying by a constant. We have another sequence that's called an arithmetic sequence. Now, it's spelled arithmetic, but it's pronounced arithmetic when it's in the context of a sequence. And what an arithmetic sequence is it's terms that increase or decrease by a constant amount. What that means is it's in every term you might have to add 3 to get the next one. And we'll take a look at some examples. So for example, let's find the first 4 terms of these 3 sequences. A sub n is equal to 3n minus 2. A sub n is equal to negative 1 to the nth power over 2n minus 1. And then the third will be a sub n is equal to 3 plus negative 1 to the nth power. All right, so the first term a sub 1 is going to be 3 times 1 minus 2. A sub 2 is equal to 3 times 2 minus 2. And a sub 3 is equal to 3 times 3 minus 2. So 3 minus 2 is 1. 6 minus 2 is 4. 9 minus 2 is 7. All right, so you can see that we're adding 3 each time to get the next term. 3, 3, right? So that would be an example of an arithmetic sequence. All right, so let's try this one. A sub 1, a sub 2, a sub 3. A sub 1 would be negative 1 to the first over 2 times 1 minus 1. And then a sub 2 would be negative 1 to the second over 2 times 2 minus 1. And a sub 3 would be negative 1 to the third over 2 times 3 minus 1. So negative 1 over 2 minus 1 is 1. Negative 1 is the first term. 1 over 4 minus 1 is 3. So 1/3 is the second term. Negative 1 over 6 minus 1 is 6 minus 1 is 5. So negative 1/5 would be the third term. And then for the last one, the first term, second, and the third term. 3 plus negative 1 to the first, 3 plus negative 1 to the second, and then 3 plus negative 1 to the third. All right, so this would be 3 plus negative 1 is 2. 3 plus 1 is 4. 3 plus negative 1 is 2. So this is going to oscillate between 2 and 4. Next, I would like to talk about a recursive sequence. And what a recursive sequence means is this is a list where terms are defined using previous terms. So for example, write the first 4 terms of, we'll talk about 2 here. The first is a sub n is equal to a sub n minus 1 plus 3, given a sub 0 is 6. And the second, we'll talk about what's called the Fibonacci sequence. Which I'll talk about more at the end of this lesson, given a sub 0 is 1 and a sub 1 is 1. The Fibonacci sequence says that a sub n is equal to a sub n minus 2 plus a sub n minus 1. So let's do these one at a time. The first one, we want to write the first 4 terms. So we'll start with the first, then we'll write start with the initial term, a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. We'll do the same thing with the Fibonacci sequence. We'll list a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. All right. So for a sub 0, we know that that's 6. This was given. To get a sub 1, right, so in this case, n is going to be 1. According to the formula, if n is 1, we're going to use a sub n minus 1 plus 3, or a sub 0 plus 3, A sub 0 is the previous term, which was 6 plus 3, which is 9. For the second one, n is 2. So according to the formula, a sub n minus 1 plus 3 means a sub 1 plus 3, which was the one before this, a sub 1, we just figured out was 9. 9 plus 3 is 12. And this is how this pattern continues. You use the previous number, 12 plus 3, and that's 15. For the fourth one, you use the previous number, a sub n minus 1 plus 3. That's how recursive sequences work. Now with the Fibonacci sequence, we know the initial number is 1, the first one is 1. To get the second, remember n is 2, we're going to do a sub 2 minus 2 plus a sub 2 minus 1, or a sub 0 plus a sub 1, which would be 1 plus 1, or 2. It's a fancy way to say you take two terms before plus the term before. So to get a sub 3, we're going to take a sub 1 plus a plus 2. To get a sub 2, we took a sub 0 plus a plus 1. So that's how it works. So a sub 3 would be a sub 2 plus a sub 1, which was 2 plus 1, or 3. And a sub 4 is going to be the last term plus the one before that, which was 3 plus 2, or 5. Now these numbers are significant. We'll talk about why in a little bit. Next, we'll talk about what's called factorials. Now what a factorial is it's a multiplication with all prior natural numbers. So for example, 5 factorial would be all the numbers before 5 times 5. So like 1 times 2 times 3 times 4 times 5. 3 factorial would be all the numbers before 3. 1 times 2 times 3 times 3, right? So 1 times 2 times 3. A couple definitions. 0 factorial is always 1. And anytime you see n factorial, that's all the numbers before n. So we could write that like we don't know what n is. N could be 8, which would be 1 times 2 times 3 times 4 times whatever times up until the very last number, which would be n minus 1, like 7 in this case. If n was 8, n minus 1 would be 7, times the number itself. So let's take a look at some examples. Find the first 4 terms with n equals 0 as the first term. So let's see this one. How about a sub n is equal to 2 to the nth power divided by n factorial. And if we want to get the first 4 terms, we know a sub 0 let's see here. All right, so this is going to be 2 to the 0 power over 0 factorial. Anything to the 0 power is 1, so we have 1 over 1, which is 1. A to the first is 2 to the first over 1 factorial, which would be 2 over 1, or 2. A sub 2 would be 2 to the second over 2 factorial, which is 4 over 1 times 2, or 2. A sub 3 would be 2 to the third over 3 factorial, which is 8 over 1 times 2 times 3. So 8 over 6 is 4/3. And then the fourth factorial, the fourth term would be 2 to the fourth over 4 factorial, which is 16 over 1 times 2 times 3 times 4, which would be 16 over 24. 12 times 2 is 24, which would be 8 over 12, which is 2/3. Usually when we're talking about the first 4 terms, well, in this case, I told you n sub 0 is the first term, right? So this would really be the first 4 right here. Let's try a couple more. What about if I asked you to simplify factorials? And the first one looked like this. What if it was 8 factorial over 2 factorial times 6 factorial? Well, 8 is really just 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. 2 factorial is 1 times 2. 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. So if we were going to simplify this, I could really write 8 factorial as 6 factorial times 7 times 8. So that might make things a little bit better. I mean, we have a 6 factorial on the bottom, so we could have just canceled these out, and we'd get 56 over 2, which is 28. Generally, if we have anything lower in the denominator, I would just write 8 as 6 factorial, cancel those out, and then the remaining 2 numbers I would just multiply together. A couple more. What if we had 2 factorial, 6 factorial, over 3 factorial times 5 factorial? The way I would break this up is I could see that 2 and 3, maybe I could do something with, and the 6 and 5, I would do the same thing. So what I would write is I would write 2 factorial, but instead of 3, I'm going to make it 1 times 2 times 3, or just 2 factorial times 3. Instead of having 6 factorial, in order to simplify that with the 5, I'm going to write it as 1 times 2 times 3 times 4 times 5, or 5 factorial times 6. So I could actually cancel these, and you just wind up with 6 over 3, which is 2. All right, we'll do one more. And that's if we have n factorial over n minus 1 factorial. Well, remember what n factorial is. We talked about this in the beginning. N factorial is really just 1 times 2 times 3 times 4 times whatever, all the way up until the previous number times n. Or, rewriting this is really just n minus 1 factorial times n, and you could see we could easily cancel that out with the denominator. All right, so I'm going to make a separate video actually for the Fibonacci sequence about the origins of that. I'll post that after this one, but what I would like you guys to do for homework tonight is on page 625. I would like you to please do numbers, well, it goes from 625 to 626. I would like you to please do numbers 9, 17, 21, 25, 27, 31, 33, 73, and 75. All right, good luck. Have a nice day.